to Notion page or the Wi-Fi password. Wi-Fi password if you need it. Who is not in the Telegram group?
Usually using a Telegram group?
Yeah, I can. Okay, let me show you the QR code if you're not.
ETHTaipei, March 21st to 24th. That's the one.
Or you can just scan the QR code. Do anybody need QR code to the Telegram group? Yeah. Here you go. Okay, I think this is mostly our crowd today, and I think we don't need the microphone, so let me just talk about it. Okay. So, first of all, we're happy to have you guys here to join us at the roundtable discussion. And today we have many awesome talks, right? Either from Jay or Nam. And in this roundtable, we'll mainly focus on the application side. So the too technical detail is not the point of today. Yeah, so today's agenda will focus on discuss with each other. So if you have any thoughts, just speak out. Yeah, share with everyone. Yeah, so the agenda will start from a quick, brief talk from Jay and then to introduce FHE and MPC. And after that, we'll discuss some open issue. And after the discussion, the final part, we might want to split into like 2 to 3 groups over there in the table at that area, and get a deeper view about how you can do with MPC and FHE to solve some real-world problem, and maybe incorporate with your own project. Okay. So without further ado. There's another thing that the Telegram group, there's a link that you can take note inside. It's a Notion page. So if you have any questions or feedbacks, you can just put it on the Notion page. Yeah, and we all can see that. Okay, so without further ado, maybe you can have Nan to share the talk about MPC.
Hello everyone, I'm Nam. Can you hear me well? Okay.
Yes.
So before I start, I want to have like a question. How many of you here is a cryptographer? Like actually studying math cryptography and then like composing protocol and improve them?
Studying or just implementing? Like draw the line.
So that is the next question. So actually write paper on it, like doing things. Okay. So I'm one. So, like the only one here. So how many of you like familiar with ZK, like doing implementation, and can actually like transfer that knowledge? Oh yeah, several of you here.
This guy definitely knows something.
Well, I shouldn't count them because they are like semi-host of this roundtable discussion. But so. My point to make here is that not many people are like in formal cryptography and also in like very technical cryptography. So like the majority of us is application builders, and unfortunately there are very few resources that is made available about this aspect of cryptography, right? So we have like many good math tutorial on Halo 2, on Circom, like how do you produce a proof with ZK, but like about how do you compose an app using those, we have very few, right? I think like I've seen it before, one slide by Gopship about like privacy preserving application, and that's it. And I'm not sure how accessible is that. Maybe he gave the talk in one conference and then that's it. So I think like we can do more about that. So that is the goal of today. I want to do some introduction about MPC, and we'll relate a little bit with ZK. So we can understand how an application transits from ZK to MPC, what we can upgrade from ZK to MPC. So MPC stands for multi-party computation, right? It's a secure primitive for us to build privacy-preserving application. Any application combined with MPC will allow you to preserve some private input to yourself. Still, we have the correct computation and have the outputs that we want. And it doesn't really limit to just two-party. I mean, two-party is the most common case. If you think if you think about like human interaction. Some companies, they may try to have like more parties joining in. You can think of like hospitals doing statistics together. And there are also giants like Google, Microsoft, Facebook, Amazon try to do some inference, do some computation statistics on the customer data. Right? So like privacy is like a must in those cases. So now in Web3 we have like transparent data. In Web3 we have transparent data. We try to introduce ZK for scalability. Right? Using this verifiable computation, the goal is to save costs on chain. We can also do something like ZK. So, but that allows only like privacy to the prover. So if we think about ZK-ML, in the last Dev Connect, Kati gave this like 4 dimensions, right? You can either, so ZK-ML has very good application in automation. So nothing is private. You can also have either the model from the company that is private, or the sample from the client is private. But you cannot have both using just ZK. So MPC allows you to upgrade a feature. That is, you can have both the private model and input the sample at the same time. Right? So what I think about like using MPC in building application is that if you are from like non-ZK world, right? You can think of, so I'm having some computation, I want to put it on chain, but I don't want anybody to look at my data. MPC is the right tool because it allows you to do like private computation for 2 parties or even more, right? If you are from the ZK world, you are used to verifiable computation, but you really need the capability of having more than one party to have the private input, right? For example, I mean, so most of the examples are actually from the financial world. Like if you're doing order book matching, you don't want your order to be known by the other party because they can play games, financial games on you, right? So MPC is the right tool. So I think of that as like upgrade of ZK to MPC. Yeah, so I mean, it's just as simple as that. As application builder, we can focus on that aspect. We take an application, we think about it. What is the private feature that we want? What is the sensitive data that we want to expose to the other? And we try to protect it. And that is also how, well actually, that is also how cryptographers look at the problem when they build application. They just define this, and then later they can have a construction that realize this. So, like this approach is a very, very natural, like proven procedure from 1980s. So, like 40 years, 50 years, maybe it will be the correct way for the future. Yeah, so that's all. I mean, MPC is simple. You can start building using.
Thank you. If you have any questions, just put it on the Notion page first, and we can discuss it after the introduction by Jay. So maybe Jay, now you can introduce about other.
Yeah. I think it would be better if I stand over there because people are turning heads and probably going to make my mic sprain. So am I visible over here?
Okay.
Not problematic at all?
Walk in the middle.
No, I just don't want to be walking in the middle. That's too problematic.
Do you need a microphone?
No. Am I audible at the back? Sounds good. Cool. So my focus area is more on FG, fully homomorphic encryption, and probably more useful for actually this particular setting is an interactive way of doing this thing. So I would just take 10 minutes and I would ask just ask you guys to raise your hands if you have any question in the middle, and I'll happily answer those questions. And stop me anywhere that you want me to stop at. Don't throw bottles at me, don't stop me, but just raise your hand, let's stop. Cool. So first I'll try to introduce and give you an intuition about FHE, and then I'll try to introduce a few applications, the things that when we write FHE stuff, we sort of imagine that developers will be developing these things. So, and then I'll try to briefly introduce those applications as well. So the way I think of FHE is a simple black box. Think of like a FHE server, right? It's a black box, and whatever happens inside that server cannot be viewed by anyone outside. So if I hand over my data to that particular server, the server can perform computation on top of the data. But we would never learn, neither the server would ever learn what the data is. Right? So you encrypt everything, give it to the server, it performs some computation, and it produces an output. And that output is the function evaluated on your data. That is it. That's FHE. Now FHE works in a single key setting where you have a particular user, that is me. I encrypt my data, give it to the server, and the server, let's say, has a patented model. Let's say they are AI folks, and they train a very precious model. And they do not want me to download it, but I want my data to stay private all the time, right? So I encrypt my input using my secret key, give it to the server. Server evaluates the model on my input and produces an output, and I get the output. So me and server both are happy. They keep the data, they keep the model private, and I have my data private. Now, viewing FHE from this view is somewhat limited because there's only one secret key owner. FHE also works in threshold setting where you have multiple users. Let's just say you have multiple friends and they want to participate together to figure out a very simple thing. Let's just say they want to figure out who is let's just say they want to participate in an auction, right? Someone is trying to auction something off and they want to participate in an auction, and you need to figure out which one bids the highest, right? So I can have private inputs. All these folks would participate in a distributed key generation operation, and then they will encrypt their bids and will simply hand over these bids to the server. The server would perform on these FHE ciphertext and calculate the maximum of these, and then output the maximum value. And the friend who bid the highest would have the identity corresponding to that, and you can just decrypt it and find out who the winner is. So this is the threshold setting of FHE. Now, one view I would like to have, the way I imagine this thing, the way I find FHE useful to be in is when you are building applications for the user. Because if I'm working on a phone, all I can do is that I can send a few MBs of data to the server. In FHE, it is very computer expensive for sure, but the entire compute is handled by the server. The client does not need to do anything. The client only needs to encrypt certain things, certain few things, and just send it to the server. So in scenarios where you're building user-facing applications, FHE sort of shines in this way because you can just offload everything to the server. And like we have seen in ZK space as well, you just offload everything to the server. And I believe that that's the right cost model when you sort of build user-facing applications. because now the user is not bottlenecked. If the only thing that is bottlenecked is the server, and you can build any application, like any complicated application, and just speed up the server. Cool. Does it make sense? Any questions?
Yeah, I'm new to like both FHE and PC world, and like so my current understanding is that like both FHE and PC you have like multiple parties and they have private inputs, but FHE is kind of like they encrypted the inputs and handle all the computation to the server. And PC is kind of, they have to, one party perform some computation and then send some result to the second party, and second party compute some result. And so far it's correct?
Yeah.
And like, and how do we like, you know, like what's the trade-off between these two approaches, and like when should we like choose one over the other?
Should I?
Yeah, please go ahead.
So the trade-off is pretty clear in this case, because in MPC world, the two clients would have to stay online all the time, or 3 clients, 4 clients, whatever that is, and they will have to send data to each other. Now the data could be very high, like it could range from GBs, like from MBs to GBs. In FHE world, they just come online for the first time. They perform distributed key generation operation, generate the keys, upload the keys to the server, and that is it. They can sleep after that. And they encrypt their stuff, hand it to the server computes, and returns the ciphertext, and that's it. So there is, first trade-off I would say is the likeness thing. All the parties need to stay online in MPC world. In FHE world, they just come online once, they sleep after that. The second thing is, in FHE, the only bandwidth cost that you have is to upload the ciphertext and probably the keygen operations. In MPC, you will have a constant communication. But now I'm being biased towards FHE in this case because I am more from FHE side. Probably now I'm going to be able to be more explicit in this case. I'm sorry.
Would I need to pick it up?
Yeah. Because I like the way I'm thinking, it's being more biased towards FHE for some reason.
Yeah. So thanks. I've been talking about MPC, right? So MPC is actually the term for collective of technology, including FHE.
Oh.
So like the techniques that we can use to realize MPC, we can generally divide them into 3 categories. The first one is called Gabo circuit. The second one is called secret chain base. The third one is called FHE. So these 3 approaches, they have different trade-offs. So for Gabo circuit, very low computational complexity. I mean, they just you do a bunch of AES, even using the same key. That is called fixed key AES, and fixed key AES. You can run it like using a native instruction in the CPU. So like there is no instruction loading, just feed the data and then it gives you the output. So very fast and also standardized, right? The problem with that is you have to do a lot of communication, but only in terms of bandwidth. You have constant round, so you just send the data and then and that's it, right? If you don't care about the output, right? So that is like low computation, high communication, low round. So that is for Gabo circuit. For secret chain base, you have also low computation, low communication, but high round complexity, because you have to do this back and forth, right? And then for FHE, you have high computation, but you have this freedom of like not everybody has to stay online, and then like you can do like there is no route because you just send a ciphertext and that's it. If you don't care about the output, of course. Yes, please.
Question. So in secret sharing based schemes for MPC, you say constant communication. I was rather expecting the communication routes to be linear with the complexity of the circuit that you're evaluating?
It's quadratic.
It's quadratic.
Yeah, it's quadratic.
And it is quadratic with the number of party as well?
Quadratic with the, yeah.
Okay, so it is like if you have n parties and you're increasing the complexity, then it is n squared. No,
it's n square, and then linear with the circuit complexity.
Okay, so yeah, so what I'm trying to get into is that if you have n parties, it scales quadratically. The communication in MPC, am I correct?
Yes, yes.
It scales quadratically, and it scales linearly with the complexity of the function that you're trying to evaluate. In FHE, I would say the communication stays constant because you just need to upload it to the server. The complexity on the of the computation on the server is linear.
Right.
It is like as complex as it gets, but like it grows linearly. I would also like to confirm one thing: in Carbon circuits, for generating the BO triplets. No, wait a minute. That's for secret sharing, right? Yes. Okay. For Carbon circuits, what's the size of the Carbon circuit? Like, is it linear with the complexity of the?
It's linear with the circuit size.
Linear with the circuit size. So, and the combination cost is combination cost is also the linear.
Like there are two parties.
Yeah, it is also two party, right?
Yeah. So like saying you have only one pair. That's it. But in the case of secret sharing base, you have more pair. But you can also do secret sharing base for two parties. Yeah. Please.
Sorry. I just wanted to confirm with you that there are specialized MPC settings wherein the delegator doesn't even have to be online, right? You can send some pre-processed material to the nodes and then it can go offline and just take the results back at the end.
In that case, the delegator is handing over the secret data to all these nodes.
Not secret data exactly. Some pre-processed material which will help with the keyword results that the user is expected to send. And so here the user doesn't really have to, so from the user experience standpoint it's a little better because you can go offline and just.
Yeah, but what happens to the user's private data? Does it still stay private?
No, you don't really send the raw witness data.
Sorry.
You don't send the raw witness data from the delegator standpoint.
Okay.
You mask that and send some pre-processed material with that. So there was like a specialized MPC protocol built for ZK delegation, which like tried to do something similar where the user can go offline and just send the private witness data to MPC group and then just get back the proof generated.
Okay. I'm not familiar with the work, but probably I would like to.
Yeah, sure. It's called ZK SAS maybe. I can share that.
But I'm still confused about, like, you mask the data. Does that mean that like how does the server, like, in order to generate the proof collaboratively? I believe you're in collaborative setting, right?
You are in a collaborative setting, but the delegator doesn't really participate in that collaborative setting.
Yeah, but like, in order to generate, like you said, it's ZK proofs. In order to generate a ZK proof, we need access to the witness.
Yes.
So how do these servers get access to the witnesses?
So at the beginning, the delegator secret shares that among the nodes, and then they use those secret shares among themselves, and then
okay. So when these servers come together, they can get the witness.
Yes.
So they could collude against the user.
That problem.
Yeah, that's what I meant. Like the user is leaking their privacy to these. So that's what I meant.
Yeah, it's like a semi-honest setting.
Yeah.
You expect at least 50% of the nodes to be honest.
It is 50%.
Yeah.
It's not NMS.
You can make that malicious security.
Okay.
But I think that paper was.
How does the complexity increases with the trade-off of this?
It should be quadratic.
Okay.
I have a problem. So seems like using FHE, like the only thing on the user side they have to do is to encrypt the private input, right? And send it to the server, whatever it is, the black box will do the computation and send back the result. So, like if my private input is an image, let's say 4 MB, is it feasible in the state of art FHE? Yeah.
It just the larger the image sizes, the more the communication you'll have to do. That's it.
Oh.
Like the larger let's just say that 4 MB, right?
Yeah.
No, I cannot give you exact numbers because I don't remember everything on the top of my head. But let's just say every bit expands up to probably 50x. So you just have to upload 4 MB times 50.
Oh, it's like 200 MB.
Yeah. That's it. Like you just. So there's a measurement called cipher, like plain text to cipher text ratio.
Yeah.
In most cases, it's 50x.
Oh.
So you can just, or probably, but it depends on how optimized your circuit is. But like, yes.
So if I, like my private input is like a photo, I want to like tell the government that somebody parked their car wrongly on the sideway and it blocked the way people walk. And I want to have this as private input. So if it's like 4 MB, I have to, if I using FHE, I have to like have like 200 MB's data, encrypted data, and send it to the server.
2000.
2000?
Because that's 50, right?
Oh. What was I 2 should be?
Oh, your initial data was 2 MB. Oh, 4 MB. Okay, sorry, my bad. I'm bad at math.
So is that feasible in like the mobile device so far? Maybe our phones?
I don't know. Like, is it okay to upload 200 MB? But just to take my word for 50, it could be 100x as well. I'm just giving you a number.
I see.
Usually it is 52 something. But like, you will have to devise a circuit that is optimized for this thing. But in usual cases, it's not. Like, even for, let's say, in most cases when you work in ML setting, you sort of like crop the image to a small thing. So the image is very small. Like, for reference, the image are like 128 pixels, something like that. So it's not like really big.
So maybe do some pre-processing before you create the private data.
Because if you're using an ML model that already exists, like if you're porting a model from PyTorch, and you're sort of like fine-tuning for your purposes, then the input images for those models are very small. And the reason for that is like training an ML model of big images is very expensive. So a lot of people that have already pre-trained models, they are very small. They use very small training images. And that is very suitable for FG because the moment it is small, you're okay with it. But like even if it sort of increases in size, the increase is linear. It's not quadratic.
Well, it seems that we are into the open discussion right now.
Yeah.
I have a question. So since we're dealing with multiple parties, is there anything architectural that is related to like the order of the participants engaging into that computation? Like, can it be asynchronous or should it be all synchronous, like everyone submits their inputs and then the computation happens, or is any kind of asynchronicity possible in either FHE or MPC?